study section 3, measures of central tendency. Introduction. In this study section, I intend to introduce to you another descriptive statistics referred to as measures of central tendency. The measures of central tendency include the mean, the median, and the mode. Also, in this lecture, standard deviation will be calculated. Objective. At the end of this study section, you should be able to 1. Discuss the 3 measures of central tendency, and 2. Differentiate all the 3 measures of central tendency. Pretext. 1. Discuss the 3 measures of central tendency. 2. What are the differences among the mean, the median, and the mode? Content. The measures of central tendency are descriptive statistics that identify the central location of a sample of data. The central tendency of a set of data is the best single indicator describing the representative values of any sample. Measures of central tendency are very useful in discerning differences between groups of individuals. The most common ways of measuring central tendency are the mean, the median, and the mode. Each of these measures is reviewed in this study section with comprehensive examples. All these measures of central tendency have different characteristics and their computation differ. The mean. The mean is the arithmetic mean or average of a set of scores. It is calculated by summing the set of scores and dividing them by the n number of scores. That is, x bar is equal to summation x over n, where x bar is the mean, summation is the summation sign, x is equal to the score, and n is the number of scores. The mean is far the single most useful measure of central tendency available. It can be used to analyze data from interval or ratio scales of measurement. Example 1. If we have an array of scores from a sample that were randomly drawn, let's say 12, 15, 10, 14, and 8, the arithmetic mean is x bar is equal to 12 plus 15 plus 10 plus 14 plus 8 over 5 is equal to 59 over 5. X bar is equal to 11.8. While the arithmetic mean is used for ungrouped data, however, there is a particular formula by which to calculate the mean for a set of grouped data. The mean of grouped frequency distribution. In determining the mean of a frequency distribution for a grouped data, simply multiply each score by its frequency and then add up the result. Thereafter, divide your result by the number of scores n, which can be found by summing the frequencies. The formula for mean of grouped data is x bar is equal to summation fxc over n, where xc is midpoint of a class interval, f is the number of scores that fall within each interval, and x bar, summation, and n remain the same as earlier stated. To compute the mean for grouped frequency distribution, following the earlier example, the table below shows the grouped frequency distribution. In table 3.1, the midpoint is calculated by adding the lower and upper limit of each of the class interval and divided it by 2, e.g. 9 plus 13 is equal to 22 over 2 is equal to 11. To determine the mean for the group data, you sum the fx and divide it by n. That is, mean is equal to summation fx over n is equal to 700 over 30 is equal to 23.33. The median. The median is the number of scores that precisely divides a distribution of data in half. The median can be used when calculating ordinal, interval, or ratio scale data. When you are interested in the exact midpoint of a distribution, the median is appropriate statistic. 50% of a distribution's observations will fall above the median and 50% will fall below it. To calculate the median in a distribution for ungrouped data, as in case of this 10-score data. Example 2. Consider the following data and calculate the median score for the distribution: 26, 32, 21, 12, 15, 11, 27, 16, 18, 21. You need to first rearrange this score from the lowest to the highest as follows: 11, 12, 15, 16, 18, 21, 21, 26, 27, 32. When you have an even number of scores like this, you can use this formula: median score is equal to n plus 1 over 2. In this example, 10 plus 1 over 2 is equal to 11 over 2 is equal to 5.5. This suggests that the median score can be found in 5.5 scores into the array, which places it between the scores of 18 and 21. That is, 18 plus 21 over 2 is equal to 19.5. On the other hand, when you have an odd number of scores as follows: 55, 67, 78, 83, 88, 92, 98, you arrange the scores from the lowest to the highest and use the same formula. Median score is equal to 7 plus 1 over 2 is equal to 8 over 2 is equal to 4. Locate the fourth score in the original array, which is 83, as the median score while this process is used for ungrouped data. However, there is a particular procedure for calculating the median for grouped data. The median for grouped frequency distribution. To compute the median for grouped data, you may follow these steps. 1. You first divide the number of cases n in the distribution by 2, that is, n over 2. Since the median lies between half of the number of score above and below the other half of the distribution, you need to count from the lowest interval until you locate the interval containing the median. 2. You then ascertain the number of scores needed in this interval to make half the number of scores. Furthermore, you need to divide the value you obtain by the number of scores within the interval where the median is located. 3. Then multiply the value you obtain by the size of class interval. Add the result obtained to the lower limit of the median class interval and check your result by adding from the top of the intervals. 4. Finally, take away the value you obtain from the upper limit of the interval where the median is located. Considering the previous data, you can compute the median of grouped frequency distribution as follows. The table below shows the median for group frequency distribution. In table 4, 13 is equal to the number of scores above the median interval, while 9 is the number of scores below the median interval. Therefore, the median is equal to 18.5 plus 6 over 8 times 5. 5 is equal to class size in bracket is equal to 18.5 plus 0.75 times 5 in bracket is equal to 18.5 plus 3.75 is equal to 22.25. The mode. The mode is the third measure of central tendency. The mode is not calculated, rather it is simply reported once the various frequencies within a distribution of data are known. In short, the mode is the most frequently occurring score in a given distribution of scores. Example 3. In a given distribution of scores like the following: 3, 2, 2, 4, 6, 7, 7, 7, 6, 9. The mode is the value with the highest frequency, which is 7 for ungrouped data, that is, score 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Frequency 0, 0, 2, 1, 1, 0, 2, 3, 0, 1. Calculating mode of grouped data with intervals. When you have grouped data with class interval, you can either determine the crude or interpolated mode, though interpolated mode is more accurate than the crude mode. However, the two forms of mode are calculated in this study section. The crude mode is the midpoint value of the class interval having the highest frequency. Considering the earlier given data, the class intervals with the highest frequency are 29 to 33 and 19 to 23. In this case, we have two class intervals with highest frequency of 8 each. This is referred to as bimodal. However, the crude modes of the distribution are the midpoint, which are 31 and 21. If in the data there is a single class interval with highest frequency, the midpoint of the class interval is the crude mode. Interpolated mode occurs when the use of crude mode is not feasible. The interpolated mode is favored. This, of course, occurs when we have a large sample data and the distribution is skewed. In this kind of situation, you use interpolated mode to determine the mode of the distribution. The formula for calculating the interpolated mode is given as M0 is equal to LRL plus D1 over D1 plus D2 XI, where LRL is equal to lower real limit, D1 is equal to difference between the frequency and the modal interval and frequency of the preceding interval, D2 is equal to difference between the frequency of the modal interval and the frequency of the next following interval, I is equal to class interval size. Example 3.3. Calculate an interpolated mode for the following data: 70 to 79, 20, 60 to 69, 25, modal interval, 50 to 59, 21. Modal interval is the interval with the highest frequency, that is 60 to 69, where the preceding interval is 50 to 59 and the following interval is 70 to 79. To calculate the interpolated mode for this data, LRL is equal to 59.5, D1 is equal to 25 minus 21 is equal to 4, D2 is equal to 25 minus 20 is equal to 5, and I is equal to 10. M0 is equal to 59.5 plus 4 over 4 plus 5 times 10 is equal to 59.5 plus 4 over 9 times 10 is equal to 59.5 plus 0.44 times 10 is equal to 59.5 plus 4.4 is equal to 63.9. Therefore, the interpolated mode is 63.9. The interpolated mode within the modal class interval improves the estimate of the mode by allowing the adjoining frequencies to add their weight in arriving at a final estimate. Standard deviation. The standard deviation is the average deviation between an observed score and the mean of a distribution. Alarakwe, 2005, explains standard deviation to be a measure of the distance between each score and the mean of that particular distribution. The standard deviation XD is determined by taking the square root of the variance, or SD is equal to square root summation x squared over n, where x is the deviation from the mean and n equals the sample size. To calculate the standard deviation, use the following steps. 1. First, find each deviation x from the mean, x minus x bar, where x is the score and x bar is the mean. 2. Second, square each deviation, finding x squared. 3. Third, sum the squared deviations, finding summation x squared. 4th, divide the sum by n, finding summation x squared over n. 5. Finally, extract the positive square root of the result of step 4. Example 7. Let's say you are asked to calculate a standard deviation for the following scores: 6, 5, 3, 2. The table below shows the calculation of the standard deviation. Summary. In the study section, the three measures of central tendency, which include the mean, the median, and the mode were discussed and calculated using the formula for ungrouped and grouped data. Standard deviation was finally explained and calculated. This is the end of study section 3. Thanks for listening.